What's good, everyone? Welcome to the first session of Good to Better Algos, presented by yours truly, Albert. Today we're going to be looking at an algorithm from LeetCode, one of my favorite algorithm exercise sites. Index number is 860, LemonadeChange. So what they're asking us to do here is imagine that we are running a lemonade stand selling each cup for $5 apparently. Very expensive lemonade, but regardless, that's what they're telling us to consider. Customers are only paying 5, 10s, and 20s, and we have to provide the correct change to each customer. This part right here just makes it assume that the lemonade is $5. Each transaction should be $5, and we're starting with zero change at first. Okay, and returning true if every customer can get correct change. All right, so let's get started on this. Okay, so I took the liberty of copying the prompt as I don't want to keep going back and forth. Okay, also the provided test cases and a little custom one at the end, but let's run through it. Okay, what are we trying to do here? Pretty much, if the money coming in is a 5, it's potential change for a higher bill. So we probably want to store the amount of 5s we've seen up to that point in the array. If it's larger than 5, we're going to have to check the possible change values to see if change can be made. Okay. I guess, you know what, let's just start coding. I guess first thing I'm going to do is create a map, change map. This is what's going to store all the non-20 values. There's no point in storing a 20 because we can't use that for change at any point. All right, so let's just do a standard for of. Yeah, that might be more appropriate. All right, so for constant bill of bills. And just a quick reminder, I assume that the people that may be watching this are beginners just like I am. Difference between for of and let's see, a for in. Well, in this case, I'll just explain the for of. The for of is going to iterate through each element itself in the array, as opposed to the for in, which will actually iterate through the index positions of the array. So I guess as an example, we'll just do console log bill here. Okay, and then we'll do bill in bills. Okay, CL. All right, and let's run the function. Bills 1. Okay, and excuse me, I should have had this set up before we started, so you'll have to excuse me. Okay. Okay. Oh, that's weird. Oh, I see. This is what I talked about. Okay, so as you can see, the first loop, we're actually returning 555, 1020, 555, 1020. And then on the other ones, we got the index positions. So for arrays, they say that it's not recommended to do this, mostly because some people might mess with the prototype. I'm coming off the top of my head, but I think it's fine. Anyway, well, let's say bills dot let's add a property, let's say name equals Albert. Okay, now let's run it again. Now you see that, oh, actually, it's not the right place to put it to properly illustrate this. So once again, before I run it, actually I'll run it now. So what we're doing here is bills the array. We're adding a property to it with the key / index name and with the value Albert. So for the bill of bills, which is returning the yellow, you see that only the numbers are getting returned, nothing in regards to this. However, for built-in bills, and this is the pitfall where why developers say recommend not to use it, because this name shows up. Anyway, I've ranted too long for that. Let's get on with the actual problem. Okay, so we're going bill of bills. All right, so now we got all that tracked up. And we're gonna say change map at bill can equal a change map at build, whatever the existing value is, plus 1. If there is no existing value, then we're going to just set that to 1. All right, and then now, just as a test, we're going to run the change map. And there we go. We got a count of all the items in the object, or the array, now stored in an object. So, let me see. Now we're actually going to have to, no, not to do that. Okay. All right, so now every time we go to the bill, if, let's see, if the bill is greater than 5, we're going to want to check if the change map has the change for it. So if we get a 10 in here, we're going to want to check if we have enough 5s to give them a change. If we get a 20 in here, we're going to want to see if we got 15. Okay. The bill is greater than 5. And, just heads up, I am just going to try to get a working solution. That is my top priority as opposed to optimization. So if there's a bunch of excess code and a bunch of silly things just to get the job done, please forgive me. Okay, so if the bill is greater than 5, we're going to have to loop through the change map. So we're going to have to go change map. Okay. So we're looping through it. This might not be the best path. The bill is greater than 5. Okay, well, you know what? If it's not 5, it's either going to be 10. So for now, if the bill equals 10, else if bill equals 20. Okay, so is this the best way to do it? I'm not sure. It seems very inefficient, but let's see. So we're going to be looping through the change map. So, wow, another nested if statement, but let's just get it done. If change map at change, no. Oh, you know what? We don't even need a for loop. We just need to see if, I'm so silly for doing that. All right, so we just need to see if the bill equals 10, we're going to see if change map at 5, why is that? Type 5 is greater than 0, we are going to change map at 5 minus minus. Okay. Else return false, right? Right? Okay, so let's double check this. If the bill is equals 10, we need to make sure that a 5 value is in the change map. So if the change map at 5 is greater than 0, so if there's 1, we're going to reduce that number by 0, or by 1, because there's change. Else, we're going to return false. Else, if the bill equals 20, actually, yeah, okay. So if the bill equals 20, we're going to need either 3 5s or 1, 5, and a 10. Bill equals 20. Okay, so then, I mean, similar format to up there, but change map at, I know this is going to be infuriating if you're more of you, for the more experienced coders out there. I'm going to have a bunch of redundancies and a bunch of inefficiencies, but you know what? Right now, let's just get it done. All right, so change map at 10 is greater than 0. And change map at 5 equals 1. Man, this is infuriating myself. Okay, so if the change map at 10 is greater than 0, change map equals, or probably greater than 0 as well. Well, then, 10 minus minus, map at 5 minus minus. Okay, so then after we check that, that is possible change. Okay, yeah, and this is where it's gonna get even worse. Else if change map at 5 is greater than 2, we're going to change map 5 minus equals 3. Else return false. Okay. Okay. And then if we go through all of that without returning false, then we will return true. Oh, and then just so that. Okay, so I'm gonna have to. Okay. Let's try it out. True. We put in bills 1, that's true. Bills 2, it's true. And just so you guys know, I'm checking these values that I commented in. False, that's good. 4 is false, and 5 is true. Is that true? So we have 10. Oh, I see. It's a good thing I did a little custom test case here, because it's returning true when it's supposed to return false. Why is that? So when we have 5, and we check the 10. Oh, it is true. Because we got 5 coming in here, and then we got 10. So we're sending out the 5, but we're holding on to the 10. And then when we get the 5 here, we don't need to give change. Yeah, okay, that is true. That's my mistake. So, yeah, that's right. Okay, so we're going to run this through LeetCode, and let's check out our performance before any optimization. Let's bring this back out. All right, so we're going to run the code. Let's see. Hopefully it works. I found that the run code is very lenient while actually submitting. They put in some more rigorous tests. Okay, so it is working, but this is pretty bad. 24%, 36%. I don't like to solely judge my code based on these numbers by LeetCode. They are pretty inconsistent as well. Sometimes they range. However, below 50% for both is pretty bad. Look at that. So now it's 59.17. So maybe we should take maybe like 4 or 5 of these, and that'll give us a better idea of average runtime and memory usage. Wow, so this is all over the place. Okay, so do 2 more times. It's pretty wide. We're gonna have to get some a few median values in there. Okay. All right. Okay, yeah. So regardless, no matter how you cut it, it's pretty bad. And I'm not sure why it's fluctuating so wide, but it does that sometimes. Regardless, it is bad. So let's see what we can do to optimize it. Okay. I don't know what the effect is like. Bill equals 10. Bill equals 20. So right now we're doing actual checks on if the bill is 10. For a small number of bills, it might be better than putting in full logic, but I don't really have enough experience to comment further on that. So we're running through it. Okay, so we're doing this. We're adding this. Bill equals 10. And also, this is not really performance optimization. However, for single liners, I just think this looks much better. Equals 20. So we only need to do this check if the bill equals 10 or 20. Now, I mean, there's clearly a lot of ways we can improve. It's taking a bit of time to see it. In the meantime, I will do mindless formatting. I wonder if any of you guys have been there too. Get stuck and you just decide that you're going to work on formatting instead. All right. Let's see. There has to be a mathematical solution. So whatever the bill is, okay. So let's try to just copy this over. So I don't want to touch working code. Let's two. We're now changing this to 2. Okay. So let's get rid of this. Let's just experiment here and see if it is indeed. If the bill is greater than 5, what are we going to do here? Okay. So the bill is greater than 5. Let change equals bill minus 5. Right? So whatever they give us, subtracted by 5, that's the required change. Then the bill is greater than 5, the change equals bill. And just because I want to visualize where we are, okay, get rid of it. Where's all the console logs? 515. Okay. All right. And then you know what? Let's make it clear. Okay. So we're gonna change this 5 and 15. Change this 5 and 15. If we want to, so there's only 2 possible scenarios. The change is 5 or 15 or 0. I guess I should say 3. Okay. Instead of this, okay. Change is greater than 0. We got to give them change, right? Okay. Then, I mean, there's only 2 possibilities, 5 or 15. However, I would like to kind of think in foresight. You know, maybe down the line we'd want to consider maybe $50, $100, or you know, any number of bills. But at least we'll consider 50 and 100. I think considering any amount of incoming money might be add too much complexity to the coding challenge. So if it was 15, how would we do this? Change is greater than 0. Change is 5. So if we were going to consider 50s and 100s, then there'd be 4 possible. So change for 100, change for 50, 20, 10, and 5. So 5 possibilities if we were considering all the way up to 100, which is outside the scope of the exercise. So maybe I should just try to ignore it. So I mean, okay. Let's say, you know what? And instead of an if, let's do a while the change is greater than 0, because we might want to loop through it, kind of deducting kind of incrementally. So then we'll say change, oh wait, no. Okay, so we'll say change map at 10. If it exists, then change, you know what, because it's going to change map at 10. And actually, you know what, I would have, my first thought was to just use this, leverage the JavaScript's type conversion, Boolean conversion. But then I realized that the value may be 0 at this point. So, or in this map. So we actually can't use that. We're going to have to use non-strict equality check undefined. So that way, if it's just a double equals as opposed to a triple, the undefined will also check for null or undefined, no 0. Inversely, this would also work, essentially the same thing as like this. However, personal preference. So now if we did this, then it wouldn't check for null nor 0. This with double will check for undefined and null, but not for 0. So anyway, so if the change map at 10 equals undefined, it's undefined. Maybe we should do not. If it doesn't equal undefined, that might be easier to grasp logically. So if it's not undefined, change map at 10 minus minus. I think logically it'd be better to change minus equals change 10. I think it makes more sense to take the object or reduce the object map value after we subtract it, but realistically it doesn't really make a difference. So we got this. Yeah, and then else if oh wait, okay, hold on. I got a little error here because if we only have to get $5 change, yeah, if we only have to get $5 change, then we don't need to do all this. Anyway, let's just finish this incomplete and incorrect probably. Also change map at 5 does not equal defined. Okay. While the change is greater than 0, if change map 10 equals undefined. I really hate putting all these. Okay. So this actually might take care of it, I think, first glance. Change minus 10 greater than or equal to 0. Else, if change map 5 does not equal undefined, okay. This should theoretically work. So here we're checking as long as there's a 10 value available to give for change, and the change minus 10 is greater than or equal to 0. Change minus equals change map, blah, blah. Okay. And this might end up being more complicated than our first solution. And don't worry, later on, if I get too stuck or it's taking too long, or even if I finish, we'll be looking through the LeetCode discussions to see other submissions from other users who are much more talented than I am. So we got this. Shit. So Bill's 5 is supposed to, okay, returns. Oh man, this is like excessive. I'm like on the verge of deleting this. Okay, so if change map of 5, and actually this one we can use an exclamation point because we are also checking for 0 values. Else if So if we don't have any 5s left, and change minus 10 will be less than 0, we're going to return false. And it's still not doing it. Probably because it's an infinite loop. Something with this. Okay, so let's just do that there. Let's just see. Oh yeah, so clearly an infinite loop, and we're adding to the change. Why are we adding to the change? Change equals the bill minus 5. Change minus equals. Where am I adding to the change, guys? Minus equals change. Where am I adding to change? Oh man, I'm missing something here. How much is it adding by? Oh, it's by. Damn, this is like. Forgive me, my friends. Forgive me. Okay, yeah, it's. Why are we adding here? All right, guys, I'm gonna do the tried and true. First if consistent or persistent console logs. Okay, we're gonna have to. But okay, first if only the first if is hitting. Why is it adding? Change. Oh man, I don't know if that makes a difference, but you know what? I know why. Because I did this totally wrong. So it's because I'm actually decreasing the value or like the count at that point. Yeah, I'm sure most of you caught that already. Yeah, that's a silly mistake. Okay, so this might be better. Yeah, because we were, for those of you that don't get it, and don't worry, because obviously I didn't get it at first as well, but we were originally, or I was originally, taking away the count value as opposed to actual 5 or 10 value. So, I mean, I don't think I need to explain that further, but let's just see where we at. Let's run it. So true. 5 is supposed to return true. Okay, so let's get rid of this change console. Yeah, whatever. So I'm not, let's just, sorry guys, this just bugs me. All right, so let's run all the test cases. We got 1 should be true. True, very good. 2 should also be true. 3 should be false. 4 should be false. Oh, 4 is true. Let's run the first one. Oh, whoops. So it's supposed to be false. Okay, so we got an error in the logic. So this is returning true. Why are you returning true? So it's supposed to be. Well, let's check 5 in the meantime. 5 is true. So they're all returning true. No, 3 wasn't. 3 was false. Okay, so 4 is the issue. So 4 is supposed to be false. Can't give the change of 15 back, so 2 times. So what is the error in this logic? What are we doing here? And to be honest, I don't think this is going to save much runtime performance versus the first one that I had. However, this bug is using, so we got 10. So once that comes, okay, so once the 10 comes in, we're counting the 10. Okay, we got that. Okay, so we're gonna have a 5 and a 5. So at this point, we got two 5s. Then we have a 10, which we added. And then we subtract a 5. So there's a 5 and a 10. So if there are no 5s and the change minus 10 is less than 0. I mean, I hate having this many conditions, but let's try this out. And actually it makes more sense to put this here. All right, so we got this. If change 10, still returning true. Okay, so it's got to be something with this check here. This is gonna be bugging me. Can't seem to figure this out. Yeah, okay, so while the change is greater than 0, I might have to unfortunately take all this out. I mean, if I take this out and replace it with if change equals 5 or 15, it's going to be essentially the same thing as this. Excuse me. You know what? We're just going to see what it does. I doubt it's going to have big impact on performance. However, I'm just eager to see what other coders have submitted. So if change equals 5, and then else if change equals 15. All right, if change equals 5, I mean, the fact that I want to copy paste this already lets me know that it's probably gonna be the same thing. So we're gonna do change equals 5 if change equals 5. That's gonna be the same thing. It's pretty much the same thing. This is, I'm sorry guys, I led us down the wrong rabbit hole. It's gonna be end up being the same thing. However, let's just see if it does anything. Okay. Oh my god, yeah, if I'm gonna copy this chunk, I don't even need to test it really. Yeah, I'm sorry guys, wasting time. This is supposed to be an easy algorithm as well, but we're gonna bring this back in, and it's probably not going to be much of a change. Oh, it's even wrong. Okay, you know what? Considering that I already recognize that that's a poor performance solution, let's just take a look at these. We're going to look at JavaScript first. I've noticed that the Java developers tend to have generally like, first of all, the most popular in terms of votes. And also they tend to be more efficient. I don't know if that's just me. Okay, it's going to be almost exactly as what I did. Really close to it. Changes at 5 equals, what's changes? Changes 5 that exist. Okay, this is essentially the same as what I did. Yeah, I think it's almost identical. 20. Let's change. Equals bill minus 5. Okay, similar thing. If can make change, where are you? So get the drawer change return false. Well, drawer.20s and change is greater than or equal to 20. Change minus equals 20. To be honest, I'm not really a fan of this solution. It just seems excessive to have the helper. Although, you know what? I've been proven many times before, so let's just see the performance of that one. I am curious, so let's just check it. Okay, well, it seems to be a little bit better or the same as our submission. Let's try it a few more times. I am more it's only been 2 times, but I am already seeing more higher relative. Yeah, so the memory usage is much better than ours on every single run. The runtime is probably a little bit worse, not by much. What's making it better? Using an object, same as me. On here. Sometimes I have a feeling that the helper functions, like divvying up the tasks, does have a positive effect on runtime performance. I'm not entirely sure. It's just from what I've seen in my limited sample size. Let's look at some other ones because this one's a little. Okay, so after we take a few look at hopefully some different approaches in JavaScript, I'll take one more look at a Java one. Might be a little bit better. Oh, received bill. So this looks like it's a helper function. Oh yeah, it is. Okay. Bills dot. What is he doing? Probably just my inexperience, but it just looks like it's so much extra. Yeah, he even says it's long, but it's generic, so there's no. He claims there's nothing special about it, but you know, always worth taking a look. Bills dot length. Okay, so is he doing? Is he popping the original input? Bills dot length. Where's well, maybe it's just a quick exit. It might be just a quick exit, yeah. For bills. Bill equals cost. Cost is 5. I like that he put a variable here and declared that as the 5. Maybe it would have been better to put it here, but yeah, at least you can easily um, like customize this problem later on down the line. Maybe you want each lemonade to cost $7 or something of that nature. Maybe you want to start keeping track of ones and like the higher bills. So I like that. So even if I don't fully understand what he's doing, at least I got that out of it. Cost remaining with bill minus cost. Changes array, those object.keys, changes.sort. I'm having trouble just deciphering what he's trying to do here. Change, passing in all these. And you know what? Another thing that I like that he did is this he's passing in an object, self-defining variables, names and values. I think I need to start doing that. Kind of from what I've read, can't elaborate on it, but it tends to reduce the chance of errors apparently. Yeah, I'm not gonna be able to make sense of this at this moment, guys. I'm sorry. This is just it's just too much going on. If any employers are watching this video, just know if it was for real, then it might be more dedicated to the cause. This one looks interesting. It's very short. So 5 is less than 1. We're going to return false. Really equals 5. I had a 5. Okay, so he's just counting 5s and 10s without an object. I don't know if that's more or less. They're probably the same. Same as an object that we used. Really equals 5. This is 5. Let's say 5 less than 1. Also, if Bill equals 10. You know what? I'm curious to see the relative performance of this. This will be the last one before I call it quits. Do that. This one looks promising. I actually think this might be better than 108. Well, that goes to show my judgment is not very good. Oh, it is good. 90%. Wow, this is a very, very good. I mean, just there's no way it's gonna get 90% if it's anything less than. Yeah. Okay. So 79. This might be more realistic, but let's run it. Say 2 more times. So we started at 76. So it's already producing consistently better results. 30. But that's like a medium level result speed from what my solution was. Okay, so let's say this is the low average. Okay, so that's actually pretty good. I mean, not good, but compared to where I was at earlier. Okay, so it's like a C plus, B minus solution, C plus probably. Yeah, looking at the numbers, so that's a lot better than these hundreds that we've been having. Okay, so what I'm gonna do is make a copy of this because definitely need to take a record of this. Alright, so we're gonna here. Okay, so I'm gonna have to copy a link to that so we can refer to it. Okay, got that. Then we're also gonna want to update the stats on our original solution. So let's run that one more time. If I remember correctly, it was pretty low. It's like probably 20% for both categories. Oh, what? Yeah, there we go. There's the numbers, we familiar ones. Okay, I'm gonna find a more realistic one, maybe around 90 or 100 milliseconds. Yeah, this is fine. This is pretty indicative of the mode number that we've been seeing, or at least closest to what we normally see. So we're gonna do that. All right, guys. Thank you for joining me. I apologize if I spent too much time entertaining my rabbit hole ideas. But regardless, I'll see you guys again sometime soon. Until then, please be well and happy coding.